Okay, so today we're going to be reviewing for our quiz. So we got some practice problems to do. We're going to go through them and see how you do. So we're going to start just by finding the slope of the line. And on the first two, it's going to give you the 2 points that the line goes through. And the other one, it's going to give you a graph. So the first one is a line that goes through the point 6, -5, and the point -1, 7. The second line goes to the point -3, 4, and -5, 4. And you're going to find the slope of each of these lines. Okay, so when I have 2 points, I always give an x1, y1, x2, y2, and I use my equation, y2 minus y1 over x2 minus x1 to find slope. So that gives me 12 over -7, so m equals -12 sevenths. Okay, so again, if I'm given 2 points, I'm always going to use y2 minus y1 over x2 minus x1. And that gives me 0 over -2, which is 0. So in this case, m equals 0. Now, for the slope of the line, it's a little different. I have to actually count my rise over run. So the first thing I need is 2 points. I'm going to use this point and this point. I'm going to count my rise over run. I rise -2, which means down 2, and I run 1. So the slope of that line is -2 over 1, which is 2. And for the blue line, I'm going to use these 2 points here and here. Calculate my rise over run. I went up 1, and I went over 3. So my slope is 1 over 3. And that's how we find the slope of a line, whether you're given 2 points or whether you're given the line. Okay, and for these problems, all we have to do is state the slope and the y-intercept. Okay, so you've got one equation, y equals 4x minus 5, and another equation that says y plus 2x equals 4. And you need to find the slope and the y-intercept. Okay, so the first one's nice and easy because it's already in slope-intercept form. It's already in the form y equals mx plus b. So you can already see that the m is 4 and the b is -5, because the m is always in front of the x, the b is always behind the x. Now, the second one is not ready yet, because this doesn't look like y equals mx plus b. So we're going to have to make this look like y equals mx plus b. The 2x is on the wrong side. So I've got to move this 2x to the other side. I need it to look just like this equation. So I've got to move that 2x. I move a plus 2x by subtracting 2x. And that gives me y on the left. And it gives me negative 2x plus 4. Okay. Now, you could have written 4 minus 2x, but since the equation wants the x first, I had to put the negative 2x in front and the positive 4 in the back. And now, this equation looks like our formula, y equals mx plus b. So now we can see that the m is negative 2 and that the b So, you need to make sure that before you start looking at the m and the b, that you have it in the form y equals mx plus b. So if you need to move some things around algebraically, then you have to do that before you can see the m and the b. Okay, so now for these two, you're going to graph each line. For the first one, you're given the slope and you're given the y-intercept. The slope is 3 over 2, the y-intercept is negative 1. For the second one, you're given the equation. The equation is y equals negative 2x plus 1. Okay, so for the first one, I know that this is my m and this is my b because it gives me the slope and the y-intercept, and I always start with the b on my graph. So I have to go to negative 1 on the y-axis and I put my point. Then the slope, or the m, tells me where to go from there. It tells me I need to rise 3 and run 2. So I'm going to rise 3 and run 2. That was 3, 2, and there's my line. Now, as far as my line, I don't really have to have these dotted lines or the 2 or the 3 here. The line itself is what I'm looking for. Okay? Now, the second one isn't as straightforward because it gives me the equation. But I can still find m and b because it's in slope-intercept form. Okay, so the m is right in front of the x, the b is behind the x. I start with my b. Since b is 1, I go to 1 on the y-axis, and then the m tells me where to go. But it's not written as a fraction yet, so I have to write it as a fraction. So I write negative 2 over 1. So that tells me that I go down 2, or rise negative 2, and run 1. So there's the 2 points, and I draw my line. Now we're going to practice writing the equation of a line. So the first one, you're given the slope is negative 1, and the y-intercept is 0. The next one, you're given the slope is 3 over 4, and the y-intercept is 5. And on the third one, you're given the graph. You need to write each of these 3 equations. So for the first one, you can see that the m is negative 1 and the b is 0 because that's what slope and y-intercept are. So now I'm filling it in my equation. So y equals negative 1x plus 0. Yes.
Would you post attendance, please?
Oh. Okay, so I've got the m is negative 1, the b is 0, but really I don't need to write plus 0, so I can erase that. And I don't really need to have a 1 in front of my variable, so it's a negative 1. I can just use this as a negative x. So the equation for this one is y equals negative x. The next one, again, it gives me the m and the b because it gives me the slope and the y-intercept. I just have to plug it in. So I get y equals 3 over 4x plus 5. Because remember, if the b is positive, it's being added. If the b is negative, it's being subtracted. Now, for the equation of the line, I still have to find m and b first. But before I can do that, I need 2 points. So I'm going to use the point here and the point here. And I need to count my rise over run. So I can see I went down 3, so negative 3, and I went right 1. So my rise over run is negative 3 over 1. But negative 3 over 1 is just negative 3. Then you can see that the b is always where it crosses the y-axis. So it crosses at negative 1, so b is negative 1. Now that I have m and b, I can write the equation. I get y equals negative 3x minus 1. Okay, now here's two that are a little harder. We're writing the equation, but this time it's going to be from a table and given 2 points that the line goes through. And we're writing the equation in slope-intercept form. Now remember that a table really is just a bunch of points that the line goes through. So this really is the same idea for these two problems. Okay, we just have a slightly different way of finding rate of change, really. Okay, so we have a table, and then we have a line that goes through these 2 points, 6, 0, and 3, 4. Okay, so for the table, I'm going to find the rate of change. I need the m and the b to start with, no matter what. To find the rate of change, I see that the y's go up 2 and the x's all go up 1. So that means my rate of change is 2 over 1. Okay, so that means that my slope is 2. Now, remember yesterday, to find b, we have our m. We can pick an x and a y and plug it in. Now, notice, I took the m value, plugged it in for m. I took an x value, I plugged it in for x. Then I took the corresponding y value, the one that went with the x value I used, and I put it in for y. And now I have a single variable equation. So I have negative 12 equals 8 plus b. So I can subtract the 8 to the other side, and I get that b equals negative 20. So now that I have m and b, I can write my equation. Y equals 2x minus 20. Okay. Now, basically the same idea with the 2 points, except for I'm going to use my formula this time for slope. Okay, I could have used the formula last time and just picked one of these points to be x1, y1, x2, y2. Could have used it that way. Okay, so I'm going to use my formula here. Still looking for m and b first. I'm going to use my formula to find m. I have y2, minus y1 over x2 minus x1. So 4 minus 0 is 4, and 3 minus 6 is negative 3. So that means my slope is negative 4 over 3. Then I'm going to find the b the same way I did last time. I'm going to plug in an x, a y, and the m. So my m is negative 4 over 3. I'm going to plug in the 6 for the x, so that means I plug in the 0 for the y. Okay, so that gives me 0 equals negative 8 plus b. And again, you can just use your calculator to figure out that negative 4 over 3 times 6 is negative 8. Okay, and then you have to add 8 to get rid of the minus 8 or the negative 8, so you get b equals 8. So now that I have m and b, I know that my equation is y equals negative 4 over 3x plus 8. Okay, now this time we have a word problem. You're going to write the equation that explains the word problem. Alright, so there's an air conditioning guy. He charges an $80 service charge, which means that's how much you pay just for them to come, no matter how long they stay. And he charges a $50 an hour charge. So we're trying to write an equation for the cost of the air conditioner guy coming to work on your air conditioner. Okay, so you've got to still find the m and the b. Okay, as you see, the starting cost is your 80. That's b. Your rate of change is 50, and that's m. So that means your equation is y equals 50x plus 80. And this is the equation for when y is the cost and x is the number of hours that you spent working. Okay, now we're going to write an equation given a table. Okay, so the table is giving you x is time, number of hours, and phi is number of dollars. That's y. You still have to find m and b. You find m by finding rate of change, just like we always have. So y goes up 8, x goes up 4, y goes up 4, x goes up 2, y goes up 4, x goes up 2. So that means my rate of change is 8 over 4, or 4 over 2, or 4 over 2, which is all the same thing, which is 2. So that means my slope is 2. Then I notice that my y-intercept is actually already in the table. When x is 0, that is the y-intercept. So b is 5. So my equation is y equals 2x plus 5. So the slope of 2 means that it costs $2 for every hour. And the y-intercept of 5 means that it costs $5 just to start. Okay, and finally, we're also going to have a direct variation question. So this question is just to identify whether or not this is direct variation, explain why, and calculate the rate of change. Okay, so here's the graph. I want to point out that the scale is not by 1. The x-axis is counting by 100s. The y-axis is counting by 50s. So when you have this line, make sure you're careful with that. Okay. First, is it direct variation? If it's a straight line, it has a constant rate of change. It's straight, so it does. If it goes through the origin, it's proportional. So a straight line through the origin is direct variation. So this is a direct variation equation. So now we need to find the rate of change. Pick 2 points. I find rise over run. I noticed that I didn't just go up 1 and over 1. I went up 50 and over 100. So 50 over 100 reduces to 1 over 2. So my rate of change is 1/2.